All right, so this is actually number 16. Consider the experiment of rolling a pair of dice and finding the sum of the numbers on the dice. Let J be the event that the sum is less than 3, and let K be the event that the sum is a prime number. So we're going to find the sample space for the experiment. Remember, sample space means all possible outcomes. So we're rolling a pair of dice. Let's see. We could end up getting 2 1s. 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, a 1 and a 6. Or we could get a 2 and a 1, a 2 and a 2, a 2 and a 3, 2 and a 4, a 2 and a 5, and a 2 and a 6. Or a 3 and a 1, 3 and a 2. And I can continue on here. These are all adding because we're finding the sum here. 4 and a 4, 4 and a 5, 4 and a 6, and I know I'm writing really small here. 5 and a 1, 5, 2, 5 and a 3, 5 and a 4, 5 and a 5, 5 and a 6, 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. All right, we are again adding all of these together because that's our sample space, is the sum. So I could get a 2, 3, 4, 5, 6, or a 7, 3, 4, 5, 6, 7, or an 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, or 7, 8, 9, 10, 11, or 12. All right, that's my sample space. That's all of the possible outcomes. So that's question 1. Question 2, list the outcomes in event J and event K. Remember, J says let J be the event that the sum is less than 3. So let me choose a different color here. All of the ones that are less than 3 we've got 1. That would just be getting a sum of 2. Those are all the outcomes in J. K says let K be the event that the sum is a prime number. So K, prime numbers here. Well, 3 is prime, 5 is prime, 7 is prime. So 3, 5, 7. We've already got 3 in there. We've already got 5. We've got 7. We've got 5. We've got 7. 9 is not prime. We've got a 5, 7, 7. 11 is prime. 7 and 11. All right, so that was number 2. List our outcomes in event J and event K. In J, the only outcome that I had was less than 3 was when I got a 2. That happened 1 time. And then in K, the event that it is a prime number, I had 3, a 5, a 7, and 11. That happened a lot more frequently. So 3, it says, in this experiment, are you just as likely to get a sum of 3 as you are a sum of 8? Well, let's look at our sum of 3. Let me mark them in blue. And when we're talking about likelihood, we are talking about probability. So the probability of getting a 3, we had 36 possible outcomes here. 36 in our sample space. Let me see the ones that are, come on, blue please. It is not liking me picking blue. Let's go yellow. We're going to circle the ones that are a sum of 3. See how many we got. We've got 1 3 here, another 3. I think those were the only 2 3s we got. So 2 out of the 36 was the probability of getting a 3, or 1 out of 18. Now let's look at the probability of getting an 8. I'm going to make it purple. So let's look how many 8s we got. Got 1 8 down here, 2 8s, 3 8s, 4 8s, 5 8s. So the probability of getting an 8 was 5 out of 36. So it says, are you just as likely to get a sum of 3 as a sum of 8? If we compare them here, 2 out of every 36 times we got a 3, but 5 out of 36 we got an 8. So getting the sum of 8 is much more likely than getting a sum of 3. So my answer to that one is a whopping no, and here is my explanation.